Jnanam paramam dheyam. Knowledge is supreme.
So, very quick recap of symmetry classification of molecules. Okay. Now, what I see is that even in schools nowadays, they talk about symmetry elements. So, I believe all of us know what a symmetry element is, what a symmetry operation is. Okay. Symmetry, what is symmetry operation? What is the formal definition? But what is a symmetry operation? We will come to symmetry element afterwards. Well, a symmetry operation is something that we do to a molecule which leaves it in an equivalent configuration. Is that right? So, it looks the same if I put it in very, very simple words. And symmetry element is a geometric entity with respect to which the operation is performed. I find it easier to define the operation first, then go to the element. When I say geometric entity, what I mean is point, line or plane, right. So, this is a symmetry operation, this is symmetry element. Okay. Now, with the point, what do? You do an inversion. What is the meaning of inversion? You start from some point of the molecule, go to the point of symmetry, extend the line to an equal distance on the opposite side. If you reach the same entity from where you started, then that is a symmetry operation, otherwise not. Okay. Line, what do? You turn. Okay. If you can turn simply, that is called simple rotation, or you can turn and then do a reflection, that is called axis of alternating rotation, and it is written as Cn. What does this n stand for? By which angle you will rotate, 180 degree by n or 360 degree by n? 360 degree by n, very good. And complex rotation means you rotate by 360 degree by n and then you do a reflection along a plane to which this axis is perpendicular. And in plane is perhaps easiest to understand because that is what we do every day when we comb our hair, hopefully. You do a reflection. Okay. Principal axis of symmetry we know is the axis with the largest value of n. That means the axis about which we turn by the biggest angle. Is that right? Do not say yes without thinking. It is the axis along which, about which we turn by the smallest angle to get the equivalent configuration. Right. So, you see, even though you actually know everything about symmetry, you can go wrong if you are not very careful. N is large, n means n is in the denominator, do not forget. Okay. Horizontal plane means if this is the principal axis of symmetry, then this would be the horizontal plane, a plane to which the principal axis of symmetry is perpendicular. Naturally, vertical plane would be a plane that contains the principal axis of symmetry, and sometimes you have things called dihedral planes. Dihedral planes arise when, in addition to the principal axis of symmetry, you have C2 axis perpendicular to it and there is a vertical plane that bisects the angle between the C2 axis. By definition, they are called dihedral planes. Knowing this, we can do a symmetry classification of molecules. This is a table that nobody has to remember. Very nicely worked out table which nobody has to remember except for one point. So, basically you work out the point group of many molecules, it will come to you automatically. The only confusing part for me even now is this, but we will come to that. So, essentially what you do is, first of all you ask, is it a symmetry of, is it a group of low frequency symmetry? That means, is there, you can have molecules that have no symmetry element at all, then it is called C1. What is C1? Rotation by 360 degree. You take anything and rotate by 360 degree, you get identical configuration, right. So, C1 is present in any object that you can think of. So, there the name is C1, these names are called point groups. Next question you ask is, suppose there is only one plane of symmetry, then it is called CS, S for sigma, sigma means plane, or maybe there is only an inversion point, then it is called CI. Point to note is that I did not say what will it be. Oh, well, the question I asked is there any, we did not ask whether there is a point of, whether there is an axis of symmetry yet. Next thing you ask is, this is one end of the spectrum, where there is hardly any symmetry. Other end of the spectrum is molecules with very high symmetry, more than one principal axis, then the tetrahedron, octahedron, icosahedron, so on and so forth. For if you do not know this, come over, we will discuss. Then we ask, if there is only one principal axis of symmetry, what is the n value? Once you know it, you ask this question, do you have perpendicular C2 axis? If there is no perpendicular C2 axis, you call it either C or S. If you have perpendicular C2 axis, you call it D. We will take this side first. If there is D, do you have sigma H? Sigma H has highest priority. Then you call it DNH. If H is not there, then you look for dihedral angles. If that is also not there, then you call it DN. On the other hand, if you do not have C2 axis, then it is going to be either C or S. In the same way, you look for sigma H. If it is there, you call it CNH. Otherwise, look for sigma V. If sigma V is there, call it CNV. If nothing is there, this is where I get confused. So, I hope that at least one or two of you also get confused to keep me company. If it is not there, then you look for S2N axis. Sometimes even when there is no CN axis, S2N can be there. If it is there, then you actually call it S2N. Only if S2N is also not there, then only you call it CN. This is the only place where I get confused. Okay, and you do not have, now you can forget everything except for that last part. First we start with the simplest possible molecule. Well, we can think of even simpler molecules, H2, but H2 is actually complicated. So, we will start with water. What is the principal axis of symmetry? Very simple, C2, okay. This is water, turned by 180 degrees, you get the same thing. So, this is your C2 axis of symmetry. Do I have planes of symmetry? Yes. If this is water, this is one plane, molecular plane, this is another plane. So, two planes of symmetry. This is one molecular plane and this is perpendicular. Okay. It is important to understand that these are not equivalent planes, we will come to that later. Okay. So, what will the name be? Since you are doing it for the first time, what will the name be? Hey, remember this? What do I look for? I look for principal axis. What is principal axis? C2. Do you have perpendicular C2 axis? No. So, it cannot be D2, it has to be C2. Do I have sigma H? Sigma H is horizontal plane. So, if this is the axis, if there is a plane like this, then it is sigma H. But the planes that I have here, one is like this, one is like this, no sigma H. But these are called vertical planes. So, sigma V is there, right. So, this is a C2V molecule. So, was that easy or was that easy? Either way, it was easy. So, this is called a C2V molecule, simple. Okay. We will conclude today's discussion with this thing CH3, NH3. What is the principal axis of symmetry? Ammonia looks like this. C3. Do we have horizontal plane? No. What about vertical plane? You see the vertical planes? This is C3, this is one plane. How do you define that plane? A plane that contains one NH bond and bisects kind of, yes. So, there are how many such planes are there? 3. So, you draw the 3 planes, it looks like blades of a fan, nothing else. So, this is your C3V. Now, so one important difference between C2V and C3V is the action of the planes. Think of water, molecular plane, what happens? No atom changes position, right. If you use the plane that is perpendicular to the molecular plane, then what happens? No, this hydrogen atom goes here, this hydrogen atom comes here, isn't it? If you use the perpendicular plane, this like this hydrogen atom will go here, this hydrogen atom will come here, okay. So, the action of these two planes are not the same. However, if you look at this, action of any plane is that this nitrogen does not change place, hydrogen atom contained in that plane itself does not change place, the other two hydrogen atoms change place. So, all 3 planes here are equivalent, or what we are going to say later, they belong to the same class. The 2 planes here are non-equivalent, they belong to different classes. Okay. We will stop here today, and what I will do is I will upload the slides. Next day what we will do is we will discuss how we can convert all these geometrical operations to try to write an algebraic equation.